Particles are made up of three different parts. They're made up of protons, electrons and neutrons. Now the protons carry a positive charge, the electrons carry a negative charge, neutrons carry a neutral charge, no charge at all. So we can find these protons, electrons and neutrons in various places of the atom. The first one that we're going to look at is protons. Protons are found in the middle of an atom in something called the nucleus. Protons are joined in the nucleus by something called the neutron, as we said. Now, electrons don't like to go to the nucleus, they like to hang around the outsides, and they occupy something called a shell. A shell is just basically a region around the nucleus. So I'm going to draw our shell in as just being a circle. So there's a circle around the outside of the nucleus, and this actually represents what we call an orbit. So the electron could be anywhere within that circle around the outside of the nucleus. So I'm going to draw my electron in, and I'm going to represent my electron as being a red dot. Okay, now if you can just notice that I've only added one electron in here. Now the reason for that is because the number of electrons always balances the number of protons within the nucleus. So it makes it an overall charge balanced, so zero charge on this atom at this point. Now this becomes relevant a little later when we're talking about ions, which are electrically charged. Now there are rules that apply when we're talking about electrons and the way that they occupy shells around the nucleus. So I'm just going to represent the nucleus as just a dot in the centre, just for this purpose. So around the outside we have our shells, which are areas that electrons can occupy. So the first shell, or first area, only 2 electrons are allowed in this area. That's it, 2, no more than that. Around the next area, which we call the second shell, you can have 8 electrons. You can't have any more than that, just 8 electrons. Sometimes some of the elements have less than 8 electrons orbiting on that second shell, but you can never have more. You can have a third shell, and again, 8 electrons can occupy this space as well. So again, you can't have more than 8 in that shell, just less. So it's a little bit like a game where you can only have 2 players close to the middle, then 8 players in the next one, and then 8 players again. Now we can represent this electron structure by writing the numbers separated by a comma. So for this example, you'd have 2 players or 2 electrons even in the first shell. You'd have 8 electrons in the next shell and 8 electrons in the shell after that. It's worth remembering this rule, so I'm going to just write it in the corner. So 2, 8, 8. And we're going to keep that there as a constant reminder of how we occupy these shells. So if we think about our periodic table, the periodic table has these numbers attached to it just here. And this is called the atomic number. And what this atomic number represents is the number of protons. So here's our protons, which can be found in the nucleus. So, as an example, if we have a look at beryllium just here, we can see it has an atomic number of 4. So, beryllium has 1, 2, 3, 4 protons within its nucleus. Now, as we said before, that the number of protons is equal to the number of electrons, we can arrange the electrons around the outer shell, paying attention again to our rule. So in the first shell we are going to have 2 electrons. I'm going to represent them by these red dots again. And in the next shell we'd have 2 more electrons. 1, 2. Now as you can see that these add up to the 1, 2, 3, 4. And we have 1, 2, 3, 4. So the number of protons and the number of electrons are balanced. So 4 protons and 4 electrons. Now atoms are funny things. They don't like to have any less or any more than 8 electrons in its outer shell, or 2 electrons if you're talking about helium, lithium, beryllium and boron. They don't like to have any more or any less than 8. They're very OCD about it. They don't want anything less or more than that. So what they do is they try to give their electrons away, or they try and pinch them off another atom. They're quite happy to pinch or to give away, quite charitable. So what we're going to do is have a little example of that. So I'm just going to put those down into the corner. So let's have a look at the example of lithium just here. Now lithium has got an atomic number of 3, so we know that that means it has 3 protons in its nucleus with 3 electrons orbiting around it. So I'm going to represent the protons with little pluses, so 1, 2, 3 in our nucleus. And then in our first shell, which is our first area that the electrons can occupy, we've only got 2 if we remember our rule. And so we have 1 and 2. And in our second shell, we have that other electron, so it's going to occupy that space just there. So as you can see that the number of electrons just here balances the number of protons. So we've got 1, 2, 3 protons and 1, 2, 3 electrons. Now what happens is the outer electron that we've got just here, that is actually given away by lithium. It gives the electron away because it doesn't want to have just that one electron in its outer shell. It's quite happy to have that full inner shell complete with 2. So what it does, it gives that electron away to other atoms instead. So I'm just going to put that to a side and we're going to have a look and see what happens. So I'm just going to very quickly draw our atom again. So 1, 2, 3. And then our shell, 1, 2. So there you go, that's the electron structure of lithium if it's given away its outer shell. So lithium still has 3 protons, but this time it's got 2 electrons. So as you can see that it's got 1 more proton, which is positive even, compared with the 2 electrons that it has, which is negative. So what we will do is we'll put a box, or a square bracket is the correct term for it, around this atom to show that there's an electron missing. And what we'll do is we'll actually show that that electron has gone missing because we have that 1 more positive here than we have negatives. So what we can do is we can represent that by putting a positive in the corner just here. So this has now become what we call a cation, and a cation is a positive ion. Okay, I'm just going to put that to one side, and now we're going to have a look at what happens at the other side of the periodic table to the elements found in this area just here. Now rather than giving away their electrons like they do at this area of the periodic table, when you look at these group of elements just here, they tend to gain electrons, or pinch electrons from other atoms. So we're going to have a look at the example of fluorine. So fluorine, as you can see, has got an atomic number of 9. So that means that it's got 9 protons, and it also has 9 electrons in its outer shell. Protons being positive and then electrons being negative. So I'm going to just draw that very quickly. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. And I'm just going to draw electron structures. So there's our first shell, 1, 2. Our second shell, 3, 4, 5, 6, 7, 8 and 9. Now as you can see just here that there's a space missing. Now we said that atoms like to have a complete shell, so it likes to have 8 electrons in its outer shell. It doesn't really want to give each of these electrons away because that'd be a lot of hard work. So what it wants to do really is it wants to occupy this space. So what it does is it actually goes out and it goes and takes an electron from another atom. So I'm going to represent that by a little dot so you can see the difference between the one that it's borrowed and the one that it originally had. Now, it has actually changed the number of electrons that we have present. So rather than having 9 electrons, we actually now have 10 electrons instead. So if we have a look at that, you can see that we have 10 more negatives than we do have positives. So we've actually changed the charge on this iron now. So I'm going to put a box around it to show that I've done something. I've changed the number of electrons that's present in that atom, and I'm going to represent that now by showing that I have one more negative charge than I have positive charges. And the way that I'm going to do that is I'm going to put a little minus in the corner. Now that would tell me that it has gained an electron. Represent that